In this video, we are going to compare two fundamental concepts in air conditioning and psychrometrics, specific humidity and relative humidity of the air. Although both concepts are directly related to the amount of water vapor contained in a mass of air, it is very important to understand that their interpretation and application are different. Specific humidity is the actual and absolute amount of water vapor contained in a mass of air, expressed in relation to the mass of dry air. It is normally measured in kilograms of water vapor per kilogram of dry air. This value does not depend on temperature, but only on the actual amount of water present in vapor form within the air. For example, if we have 10 grams of water vapor in 1 kilogram of dry air, that will be the specific humidity regardless of whether the air is cold or hot. Relative humidity, on the other hand, is a relative and percentage-based concept. It indicates how close the air is to reaching the saturation point, that is, the condition in which it can no longer hold additional water vapor at a given temperature. It is expressed as a percentage and strongly depends on air temperature. Air at 100% relative humidity is saturated, and any further cooling will cause condensation. Air at 50% relative humidity contains half the water vapor it could hold at that temperature. To better understand this, let's look at the following animation. Imagine we have a mass of air with a certain amount of water vapor represented by circles. When the air passes through a cold coil, such as the evaporator in an air conditioner or refrigerator, its temperature decreases. As it cools down, the air reduces its capacity to retain water vapor. As a result, relative humidity increases because the air is closer to 100% saturation. However, specific humidity does not change since the actual amount of water vapor present is the same. The only thing that varied was the temperature. Now, when the air is heated as it passes through a hot coil, such as in a heating system, the opposite occurs. As the temperature increases, the air expands and can hold a greater amount of water vapor before reaching saturation. Therefore, relative humidity decreases because the air is farther from its saturation point. Specific humidity remains the same since no water vapor has been added or removed from the mass of air. In summary, relative humidity varies with air temperature, even if the actual amount of water vapor is the same. Specific humidity only changes when water vapor is actually added to or removed from the mass of air.